Now we are going to talk about application of design of experiments to additive manufacturing and what we did on one of the earlier projects that I did. And this was related to extrusion freeform fabrication, which is a type of 3D printing. And there are some issues with the standard method of, of modifying and optimizing the experimental conditions. So what all did we have to do? First of all, we had to optimize the perimeter conditions so that when you complete the perimeter, you are not going to have excess material in one corner of the actual component, because that will completely destroy the accuracy of the part that is being built. So, I mean, all your effort is going to be for naught if that is going to be the case. So we had to, first of all, optimize the perimeter, and then we had to optimize the raster, because when you're rastering in between the perimeter, every time the raster goes and hits uh, the perimeter and returns, there is going to be a gap between those two raster operations. So you may have to go back and add additional material so that you are not going to get any kind of defects in the part. Now, if you were just going to be making a part for show and tell, it doesn't really matter. But remember, additive manufacturing in the future is all for making actual components. So you cannot afford to have any kind of defects in the part. So these kinds of things are required. So design of experiments is going to be the approach forward. And I have some examples of that, um, optimizations and how we made the parts and things like that. So this is the 3D printer. It is an old 3D printer from Stratasys, but in this case what we had to do was we had to retrofit that extrusion head, whatever the Stratasys machine had, with a special type of an extruder head, because the ceramic formulations that we were trying to make them with were extremely viscous and needed much higher pressures to extrude the material out. So this is actually making a bladed disc. So when we looked at the initial ceramic parts, uh, we immediately discovered that you had to optimize the part to improve the quality and surface finish of the parts. Because, as I said, when you are starting from a point and ending at a point, if the machine is not given the instructions to stop extruding the material much before the line ends, you are going to have excess pool of material at the start and stop points. So, and the other thing is that sometimes you are going to have variable thickness of the line of material laid down by the extrusion head. And you may also have cases where between the rasters you might have missing rods, because if there is going to be excess pressure, or if there is going to be higher viscosity material um, because of the material not being uniform, then you are going to have missing rods. So we undertook an optimization of the parameters using the design of experiments approach. And in this case, we did not use a complete design of experiments. Complete design of experiments means if you have n variables, um, and you are going to have 3 variations of each variable. So that means you have to have 3 to the power n experiments. And you may start with n variables, but they may all not turn out to be the most important ones. So you may start with that, and you may down select them down to the most important ones. So in this case, we could either optimize the machine or the materials parameters. So in this case, the materials parameters were the type of ceramic powder used, particle size distribution, sintering aids, binder system, and things like that. And we had to use a specific type of silicon nitride powder because we were making these parts made out of silicon nitride. So we had to choose that. And the machine parameters were the extrusion temperature, the nozzle diameter, the modeling envelope temperature, and flow rate, and things like that. And so we actually developed a post-processing software. So you take um, the XY data for each layer, and you process them such that you may want to add certain elements to it. Um, in this case, um, we modified it used to be called the .sml file for the chosen machine parameters. And this is before the machine interface software works on it to create the overall XYZ data. So what we had to do was we had to look at all the different variables, and um, we chose certain parameters for screening. So the screening was only done with two levels of modification. So you either had a low level or you had a high level. For example, if you were to do 5 millimeters per minute, or you could do 1 millimeter per minute movement of the extrusion head. I mean, these are based on our experience. So these are the description, the parameters, and the description. For example, the start time, the start delay is a lag time between the layers. So after you lay down one layer, you have to wait for a few minutes before the material settles down before you start making the next one, because otherwise that initial layer would be pretty soft, and if you try to go and lay down more material on top of that, it is going to make it is going to offset the previous layer, so which means it will damage the accuracy of the part. So you had to do all those kinds of things in order to make sure that the part that you are going to be building is accurate. So what we had to do was we used a software called keep I mean, you may laugh at this. It's called Keep It Simple Stupid, or KISS. No, I mean, it's actually Keep It Simple statistically, but we used to call it Keep It Simple Stupid. Um, so what we had to do was we had to do a screening experiment to find out what factors are most important in controlling the quality and surface finish of the part. And you repeat these experiments twice, and there is a 95% confidence level that a term identified as being significant truly belongs within the standard deviation. Sorry about that. And we looked at all the parameters, and we changed the different parameters to a maximum of one, I mean a low or high. and we plotted the data against the result. For example, in this case, we looked at only depositing the perimeter, and we, for example, in this case, we made a cylinder of 2-inch diameter and a height of 0.2 inches. And we measured the thickness and we incorporated that into the software. And the software would analyze the data and tell us if the probability was less than 0.10 or not. And then based on that, we would choose the parameters that had the highest chance of affecting the final results. So in this case, we plotted these. And I'm sorry this is not very clear, but you can see the effect of the levels and the probability here. And not the probability, the final results itself. So if it is horizontal, that means these parameters don't have a very high chance of affecting the final results. But if it is almost vertical, the more vertical it is, the higher the chances for this parameter to be important. So from that, we took the most important parameters and ran the results again at a 3-level. Now in this case, we took them at low, medium, and high levels. So for example, if we did those tests between 1 millimeter per minute versus 5 millimeters per minute, we took 3 of them: 1 millimeter per minute, 3 millimeters per minute, and 5 millimeters per minute. And we chose that, and again the software would do everything for us. And so we, in this case, what we did was we deposited a square sample, and we wanted to find out what is the wall thickness at multiple points. And we differentiated with the road width, how fast it was laying it down, how much pressure we were applying, etc., etc. So we made a test shape, and we also made one sample with the optimized conditions. So this showed that we were able to get, so whatever design we had in the CAD model, it exactly prepared the same part after fabrication. So this one was, again, we had to do the same kinds of things here, and we did that and measured the properties. So based on that, we were able to find what were the optimized parameters for each of those materials. And then based on that, we made the final parts. Okay. So let me stop here and I will continue with the next set.